Sky Talk, and we'll end it off in style with a short film that will show you how different celestial objects differ in sizes. So please do sit back, relax, and enjoy the show.
Everything we know about the universe comes from studying the light emitted or reflected by objects in space. By detecting and analyzing light from an object in space, astronomers can learn about its distance, motion, temperature, density, and chemical composition. Initially, astronomers detected only one type of light: visible light, the type we see with our eyes, which is actually a spectrum of wavelengths that make up the colors. Light travels very fast. The speed of light is about 300,000 kilometers per second. This means that the light from the sun, which is 150 million kilometers away, takes just over 8 minutes to get to us on Earth. So, most objects in the universe are even further away from the most distant galaxies, can take billions of years to reach us.
Yeah.
The Southern African Large Telescope. One of SALT's main functions is to record spectra of distant objects using high and low resolution spectrographs, such as its temperature, composition, and the speed at which it travels. Visible light is just part of a broader electromagnetic spectrum. Not all radiation coming from space is just visible light. Many objects emit radiation in other parts of the electromagnetic spectrum which our eyes cannot see. Different types of telescopes are used to detect the different types of radiation. Some celestial objects give off light in a variety of wavelengths, allowing astronomers a more detailed understanding of what is happening. The Crab Nebula is 6,000 light years away from Earth and is a remnant of a supernova, an exploding star that was observed in 1054 AD. These images are from X-ray, ultraviolet, optical, infrared, and radio wavelengths. These separate images can be combined to give a composite image that can be adjusted to elucidate different aspects of the nebula and how different parts of the nebula interact with each other. This is called multi-wavelength astronomy. Meerkat recently produced the clear region around the black hole at the center of the Milky Way galaxy. A black hole is an object that contains so much mass in such a small volume that even light cannot escape from its strong gravitational pull. These images are derived from X-rays. While this image is a combination of the X-ray images and the radio images produced by Meerkat. Transients are astronomical objects or phenomena which produce varying amounts of light either periodically or as once-off events. Transients are often supernovae, which are exploding stars that temporarily give off large amounts of light. They explode when they have burned up all their fuel and disperse elements created in their core into the universe. In 2017, the US-based LIGO and European-based Virgo detect gravitational shockwaves in the universe, object 130 million light-years away. SOLT succeeds and produces the first spectrum of the event that shows anomalous behavior, proving that this is no run-of-the-mill transient event. The event was caused by two neutron stars, which are very small and extremely dense, colliding together, creating an explosion of light called a kilonova, visible initially in the form of gamma rays. The collision also created a gravitational shockwave in space-time. This is the first time in history that gravitational waves generated by two merging neutron stars have been detected. The initial explosion of light was then followed by X-rays, ultraviolet, optical, infrared, and radio waves, which were also observed. The early SOLT observations showed that the explosion was relatively bright and blue. Only 2 or 3 days later, further observations by SALT, SAAO, and other major international telescopes showed that the light was dim and turning red due to the dusty debris blocking the bluer light. This was the first time that gravitational and electromagnetic waves were used together to get information about a celestial event. It was like events like this neutron star also create heavier elements in the universe, such as gold and platinum, as extreme gravity and heat fuse the atoms of lighter elements together. When large stars die and explode, they distribute these heavy elements into the universe. Under the influence of gravity, the ejected matter reforms into stars and planets. This is how our solar system and Earth were formed. Observing station at SAAO's headquarters in Capetown, from where astronomers can observe the southern night sky. This massive spread out across South Africa and other African countries, and low-frequency radio antennae in Australia. Global SKA efforts will be coordinated by headquarters located in Manchester in the United Kingdom. Also be able to survey the entire sky much faster than any radio astronomy facility currently in existence. This giant telescope will produce science that has the power to change our understanding of the universe and our place within it, so that the eternal wonder of looking up at the night sky is magnified by knowledge of its creation, composition, and architecture. From its mysterious birth, expansion, and fiery evolution over billions of years under the influence of gravity and physics, to the knowledge of where the matter that makes up our answer questions we haven't yet thought to ask.
Bands of our Milky Way galaxy. Now back to stars. Now what we're looking at is stars of different sizes and colors. main colors that are then or known of stars is those that are yellow, whitish, or bluish in color, and those that are red. The light that you basically see right now from all these celestial objects that we're looking at is not necessarily today's light, but light that could have left these objects a long time ago, depending on the distance they are from us. Some other objects we cannot even see because their light is traveling to our eyes and it has not reached us, and this is because they are very far away from us. Now, starting off with stars. Stars, similar to us humans, they can die and they are being born. Stars are born from a cloud of gas and dust called nebula. This cloud is an influence of gravity, causing these gases to collide with each other, to fuse and form helium. So hydrogen atoms fuse together to form helium, and helium, it is what makes a star shine. Under the correct temperature, a star is formed at about 10 billion degrees Celsius. And those stars that are being formed, so the outer layer will be ejected out in space, and what will be left is just the inner core. Now, materials or elements that are ejected in space are those materials that will be recycled in forming new stars and planets. And these materials that are contained within stars, the prediction is that the same materials are found within our bodies. That's incredible. Now, after this phase, which is known as planetary nebula, which has no link to planets, actually, it was just a name that was given due to how the star explodes itself. Only 1% of the billion stars found in our galaxy can only conclude their life. There was one particular star in 2019, it was predicted that it will come to supernova, and that particular star is known as Betelgeuse, can be found in the constellation known as Orion. So this particular star is on its old age, actually, and it's a massive star. So one time in that year, it started to wane, blink, and and dim up. And scientists thought, oh, this is the time, this is the moment whereby it will explode on itself. But instead, the star didn't. It is still going strong, but the prediction has not been cancelled out. It is still there that this star, Betelgeuse, will soon end its life. Maybe tomorrow, or maybe years to come. We do not know. Scientists are still waiting expectantly to see this marvelous display. However, if that particular star was to end its life today, we would only see this glorious display after 430 years later. And this is because that star is far away from us. It's about 430 light years from our own Earth. And it means in simple terms that we are far away from harm. So I don't know, should I say we are fortunate? Now, after this spectacular display, the star can then become either two things. It can be a black hole or a neutron star. Now, black hole are nothing else but masses in star that traps any that passes their way. These have strong gravitational pull that do not allow anything to pass by. They are in opposite of the law of physics, and they defy it so very much. Now, back to Cape Town's night sky. And one thing that I would like of you to take note of is that this month I considered it to be September to remember, and that is because you'll be able to see the rising of two of the outer planets. If you look on your eastern side, we see that Saturn and Neptune will be in our close proximity, and this will occur throughout the year, but please do make sure that you look up at your night sky. You'll be able to see these two stars that are lining themselves up, but in a vertical sort of line. I'm just going to flick them up again. So remember that stars are going to twinkle. There's a difference. And planets do not twinkle. They are just steady form of light that you would see in the sky. Be very bright, but if you have specialized devices, you are going to see more details. You will see the spectacle of Saturn, and that of Neptune are a bit faint. You won't be able to see those. But please do look out in your night sky for these two planets. Another thing that you'll be able to see is the full moon, and this will be our final super moon this year. So it will only start to occur on the 29th of September. Remember, if you have missed the previous super moons, remember in August, if you recall, we had two super moons. One being a blue super moon, which was actually closest to Earth, and it was just amazing. It was spectacular. It was just a big, very occurred throughout most of, even not necessarily close to each other, and that pattern to them, they imagined it to represent a harp, and they named this harp Lyra. So Lyra's brightest star is Vega. Now if you take any measuring line, here's my pointer, imaginary line moving upwards, you'll see another bright star, and that is the star Alta. Now Alta was lined up with other stars to form this pattern, but due to astronomers' artistic skill, they imagined that pattern to look like a flying eagle, and they named this constellation Aquila. Now, if you are from the northern hemisphere, you are up for a treat, because some of the constellations that I'm about to mention are mostly seen in the southern hemisphere and only a few parts of the northern hemisphere, and it is the stars that are forming sort of a teal heart-like shape, and those stars were joined together to form this, and the pattern behind that was that of a half man, half horse, and astronomers named this Sagittarius. Remember, Sagittarius is a zodiacal, meaning that the sun always passes along this constellation from December to January. Another constellation mostly seen in the southern hemisphere is that of this very bright star, and that star is known as Antares. The prediction is that Antares is the heart of this pattern known as Scorpion. And one thing to note is that Antares will soon come to supernova, well, after not billion, but years to come. I'm not sure about the approximation, but it comes from this constellation known as Scorpion, or Scorpius, the Scorpion. And another constellation that you'll be able to see when coming from Antares more towards the south and western part is that these stars that are in a shape of a cross, and that is the famous Southern Cross. This particular cross, it was used by sailors to navigate because The southern hemisphere has no brighter stars, so they use these 4 stars that are formed in a form of a shape of a cross to navigate their way. Surrounding the southern cross is another constellation known as Centaurus. Now, the last constellation that I would like to show you is more on the southern part. It has no conspicuous stars. So the stars that you'll be able to see if you have a specialized devices, otherwise using your unaided eye you will see it. And this constellation is Mensa. Mensa means table in Latin, and it was called in commemoration of Table Mountain. This is the only geological feature that actually forms or was named after, or this is the only constellation that was named after a geological feature. But other than this, we have 88 constellations that have been identified by astronomers. Most probably they still yet to come, because remember these constellations are made up of just groupings of stars basically.
No.
And because we are situated in the southern hemisphere, we can only see 56 of those. However, if you were to go in areas more or less in the equator, you'll be able to see all the 88 constellations. Now I'm just going to forward time a bit so that you see what really happens. So this is basically an illusion that is created that these constellations are in motion. Remember that our own planet is spinning on its axis. And one thing to note is that it means, as these constellations appear to be moving, is that when you want to locate a particular star, you should know that it will only occur at certain times during the day or even seasons. So right now I'm just going to play a very short film that will show you how different stars are actually bigger than our own star, which is the closest star that we have.
Is dit een ster?
Ja, dit is te goed voor die camera.
Of noting is that all these bigger stars are actually far away from our planet, and hence If we were to look using our unaided eye, the night sky, they would appear as just pinpoints of light.
En er staan nog. Toch ergens de wijkant
Dat is baie mooi. Jy gaan nie dit op 'n video kan capture nie.
Computer.